Welcome to the deep dive. Today we're heading way back in time. We're exploring the Urartian kingdom.
Right, a major player in the Near East, think 9th to 7th century BC.
Yeah, a big area too. Modern eastern Turkey, northwestern Iran, Transcaucasia.
And our mission really, for you listening, is to get into the secrets behind their distinctive red glossy pottery.
How do they get that shine, that red, without getting lost in, super technical stuff?
Exactly, and we're working from excerpts of a 2017 study, an archaeometric one.
Archaeometric, so using science to study archaeological materials.
Precisely. They compared Urartian pottery with local clays using, well, a whole suite of analyses.
Chemical, mineralogical, looking at the morphology, petrographic. A proper deep dive.
It really was. Now, the Urartians, they're famous for metalwork, right? Amazing stuff.
Oh, yeah, definitely.
But this red polished pottery, which seems inspired by those metal shapes, it's actually really significant too.
How so?
Well, finding it helps archaeologists pinpoint Urartian presence, especially in their fortresses. It's like a marker.
And it wasn't just like everyday wear.
Doesn't seem like it. It's often found in smaller amounts, looks quite elegant.
Suggesting maybe elite use, special occasions.
That's the thinking. Things like jugs, plates, bowls, and they had this famous one-handled trefoil jug, all with that glossy red finish.
Okay, so let's unpack the main puzzle, the glossy red slip.
Right, the big question. How did they do it? For a long time, people just assumed it was hours and hours of manual polishing.
Rubbing it with a stone or bone until it's shone.
Exactly. Elbow grease?
But the source material we have suggests maybe there's more to it, different theories.
Oh, yeah. Some researchers had other ideas about the slip itself, or the firing.
Like what?
Well, one researcher, Kroll, thought maybe tiny quartz crystals in the slip caused the gloss.
Okay.
Then Oxa suggested a vitrified matrix, almost like a thin glass layer formed from hydrous mica that melts at lower temperatures.
Interesting. So the heat of the kiln doing some of the work.
Potentially. Then there's Kapoor, looking at Hadi ceramics nearby.
Similar time period.
Roughly, yeah. He suggested advanced firing with basaltic materials could vitrify surfaces. Maybe the Urartians did something similar. It's a comparison point.
Or maybe inspiration.
Could be. And Kapmeier proposed that maybe low melting point elements like lithium or boron were in the slip.
Acting as fluxes.
Exactly. Fluxes help things melt and fuse at lower temperatures, potentially creating that gloss in the kiln.
So a few different technical possibilities beyond just polishing.
Right. And this 2017 study wanted to test some of these ideas by actually looking at the pottery and comparing it to local materials.
Makes sense. Where did the pottery samples come from?
They focused on Ionis Fortress, really important site, 7th century BC, built by King Rusa II.
On Lake Van.
Right on Lake Van. Big administrative and cultic center. It seems it collapsed in an earthquake sometime before 653 BC.
So likely good preservation. How many samples?
4 representative pottery samples with the red glossy slip, S1 to S4 they called them.
Okay. And the key was comparing them to local clays.
Yes, that was crucial. They analyzed 3 local clay samples from the region.
What were they?
Okay, first, a green clay from near Van. They called it Van Light, or VL.
Green clay.
Yeah, but local potters said it fires white at high temps, but gets a nice brick red around 900, 1000 degrees C.
Interesting. Well.
Then a brown clay, also from Van Dark, VD, often mixed with the green clay for cookware. It turns red at lower temps, maybe 600, 700 degrees C, but can deform if it gets too hot.
Okay. 2 Van clays and the third.
The third was different, a red soil from Bitlis, which is a bit west of Van, locally called Abusku, or BS.
Red soil.
Yeah, and get this. Traditional potters there apparently say it's not good for shaping pots on its own, not plastic enough, but they use it for slip.
Ah, that sounds like a potential lead right there.
Doesn't it? So they have the Urartian sherds and these 3 local materials.
And then they brought in the heavy scientific artillery you mentioned.
Absolutely. Chemical analysis, ICP-MS to see the elements. XRD, X-ray diffraction for the minerals.
Checking the crystal structures.
SEM, scanning electron microscopy, for super close-up images of the structure. EDS, energy dispersive spectrometry, to map elements on those images.
Wow.
Optical microscopes, too, for a wider view. And colorimetry to measure the actual colors precisely.
And they even fired their own test pieces.
They did. Made pieces from the local clays, fired them in a traditional style kiln, really trying to replicate the conditions.
That's thorough. Okay, so after all that work, What did the results start to show? Let's talk chemistry first.
Okay, chemically, the big thing was the similarity in major oxide silica, alumina, between the glossy surface layer, the GSL, on the pottery.
Shiny red bit.
Exactly. Between that layer and the bitless soil, the BS sample.
What about the Van clays?
They were different, notably higher in calcium oxide, CaO, but the bitless soil and the glossy layer both had significant iron oxide.
Which gives the red color.
Bingo. So right away, a potential chemical match between the slip and that bitless soil.
Okay, what about the minerals? The XRD results.
XRD found common minerals, quartz, elite albite hematite in both the pottery and the local clays. Hematite, again, that's iron oxide, crucial for red.
And it showed up consistently.
Yes, indicating firing in an oxygen-rich or oxidative atmosphere. They also found similar mineral phases in the glossy layer and the body of the pots.
Mostly similar.
Mostly, yeah. One minor exception, microcline. Also, the fact that minerals like calcite and dolomite weren't found in the fire test clays suggested the firing temps weren't super high.
Because they decompose.
Right. And finding other minerals like diopside or augite pointed towards firing temps probably between 800 and 900 degrees C.
Okay, so moderate heat, plenty of air. What did the microscopes show?
SEM.
The SIM images were revealing the glossy layer was much denser, more compact than the pottery body underneath, which was more porous.
Suggesting the slip was applied wet as a liquid.
Exactly, as a suspension. It allowed it to form that smooth, dense layer, and the thickness was remarkably consistent, around 0.125 millimeters.
Careful work. Very. It suggests they used a finer clay for the slip, probably with colorants like that iron and fluxes added.
And importantly,
No cracks between the slip and the body. That means they had similar thermal expansion rates. Good technique.
so they knew how to match the materials. What about the EDS, pinpointing elements?
EDS confirmed the higher iron in the slip layer, really supports the idea of adding iron minerals for color,
Okay.
but it also found higher levels of sodium, Na, and potassium, K, in the slip compared to the body.
Sodium and potassium. Why?
The researchers think they might have come from deflocculants.
Deflocculants.
Yeah, things like sodium carbonate or potassium carbonate. You add them to a slip suspension to keep the fine clay particles dispersed, stop them clumping, helps get a smooth application.
Ah, I see.
And here's the clever bit. Those same sodium and potassium compounds also act as fluxes at firing temperatures.
Helping it melt and get glossy.
Exactly. So maybe a dual purpose there. Helps apply it smoothly, helps it vitrify slightly in the kiln.
Like a specific recipe they developed. Clever. What about the thin sections? Looking through slices of the pottery.
Thin sections showed common minerals like plagioclase and feldspar grains in the pottery and some test pieces. Probably just naturally present in the clay source.
Not added intentionally.
Seems unlikely. The similar distribution across samples suggests a consistent clay source or preparation method.
Any clues about where the clay came from?
Possibly. Some samples had volcanic rock fragments, which could point to a geological origin. They also noted slight color differences in the bodies, red-brown versus yellowish-orange.
Meaning?
Maybe minor variations in the kiln atmosphere during firing. A little more or less oxygen sometimes.
Fascinating details.
Right.
Okay, lastly, the color measurements. They actually measured the redness.
They did, using L, A, and B values.
Yeah.
L for lightness, A for the red-green axis.
Yep.
The glossy slip was consistently darker, lower L, and redder, higher A than the bodies.
Makes sense. Did the test firings match up?
Yes. The Van Dark clay fired at 850 degrees C gave colors pretty close to the pottery bodies. And crucially, the bitless soil fired at 850 degrees C. Its color values aligned really well with the glossy surface layers on the actual Urartian pots.
A very strong match, then.
Very strong, and firing test pieces hotter at 850 degrees C made them look duller, which reinforces that 800-900 degrees C firing range estimate.
Okay, so let's pull all these threads together. Chemistry, minerals, structure, color. What's the big picture conclusion from the study?
Well, it really builds a strong case. The evidence suggests the Urartians were likely using local Van clays like Van Light and Van Dark for the main body of this pottery.
Okay, local body.
But for that special red glossy slip, the data points overwhelmingly towards the bitless soil, the BS sample.
Based on the iron content, the mineralogy, the color match.
All of it, yeah. It fits remarkably well with the glossy layers on the Ionis pottery.
The bitless connection. But you said bitless is, what, 125 kilometers away from Van?
That's right, about 125 kilometers west. Seems like a fair distance.
It does.
But first, the bitless region was part of the Urartian kingdom. They controlled that area, and it was known for iron ore resources.
So they had access.
Definitely. And even more tellingly, traditional potters still work in towns in the Bitlis area today.
You know.
And they still use that same local red soil, avusku, specifically for making red slips.
Wow, that tradition has survived.
It really seems so. It's a powerful link across millennia.
Still, 125 kilometers seems like a lot of effort just for pottery slip in the 7th century BC.
It does, from our perspective, maybe. But think about it. Urartu was a powerful, organized kingdom. They managed resources for complex metalworking.
Sure.
And you don't need that much soil for just the slip compared to the whole pot body. If that specific bitless soil gave them the exact high-quality red gloss they wanted, especially for potentially elite pottery,
Then maybe it was worth the effort to transport it.
the researchers argue yes. It likely wouldn't have been insurmountable for them. It actually highlights their ability to manage resources, maybe even have specialized groups procuring specific materials.
Yeah, that makes sense. It puts the pottery almost on par with other valued crafts requiring specific sourced materials.
I think so. This study really shows they understood their materials, the geology, the firing process. They were making deliberate choices, this clay for the body, that soil from Bitlis for the slip to get the result they wanted.
So, wrapping up our deep dive then. The science strongly suggests local Van clays for the body, but the key to that iconic Urartian red glossy finish was this special iron-rich soil brought all the way from Bitlis.
That's the takeaway. A fantastic insight from archaeometry into their technical skills, their resource management, and maybe even the value they placed on the specific ceramic style.
It really is fascinating, and it leaves you thinking, doesn't it? If they had this level of organization and specialized knowledge for sourcing pottery materials, possibly under elite control, what other parts of their society worked like that?
Exactly. What other technologies or large-scale projects relied on similar centralized efforts and careful resource planning?
It certainly makes you want to dig deeper into how Urartian society was structured and how they managed their kingdom. A great place to leave it. Thanks for joining us in this deep dive.